Class 9 Physics, we have done various definitions of speed, velocity, rest, motion, displacement, acceleration, etc. And we have explained three equations of motions which are applicable for the calculation of speed, velocity, distance, acceleration or retardation of the bodies moving with uniform acceleration or retardation. Now, here graphical representation of motion, distance time graph. Graphical representation of motion. So first is here distance and time graph. Distance and time graph is of two types. This means time on x-axis, on y-axis is distance. And if body is at rest, it is parallel to the x-axis. It shows rest of the body. Means time is going on changing, but situation of the body on y-axis is same. So a rest is shown by a parallel line to the time axis as here in the figure. It is x-axis, time axis, it is y-axis, distance axis. If distance is same from the x-axis, means it represents rest of the body. But if a motion is required, if motion is going on, many types of one, if body starts from rest and moves uniformly, here is time axis, here is distance axis, then it is a straight line showing that it is a uniform motion. Uniform motion, as time goes on elapsing, distance is also increasing in the same ratio. Here, ratio of this distance and time will give speed. Similarly, if body's motion is not uniform, non-uniform motion is there, then in that case the graph will be like this. Means as time is going on, distance is increasing more rapidly, which is accelerated on non-uniform motion. Non-uniform motion. This way, motion can be represented by a straight line parallel to x-axis, by a straight line which represents as time increases, distance also increases, or by a curved line which shows a non-uniform motion. Then it is distance time graph. Then if speed time graph or velocity time graph is there, speed and time graph or velocity time graph. Speed time graph or velocity time graph is there of second case. Then if here is time, if speed is not increasing, y axis it is x axis of, then a straight line represents a uniform speed, or uniform velocity, and here graph is parallel to the x axis. Second case, if speed is changing uniformly, means, or if velocity is here, velocity is changing continuously, if straight line is there, then uniformly accelerated motion. And if it is a curvilinear graph, here is time axis, here is velocity, it shows a non-uniformly accelerated motion. Likewise, this is second time, speed time or velocity time graphs. And third is accelerated motion. Then here these are some types of graphs which can be shown. Even time acceleration can also be shown on these graphs. So you see these things already. Simply you have to go through it and have an idea whenever it will be asked about graphs of motions, what kind of motion is required, you will be in position to answer the question which will be asked. Now, to derive the equation of motion by graphical method, graphical representation of motion, and to derive equations of motions. So first equation is v is equal to u plus at. This is graph. This distance is u. Here is velocity. Velocity is on y-axis. Here is time, and here velocity becomes v. Here it becomes v, uv, and here time is t here on x-axis, time axis. Then v is equal to u plus at. A is what? Change in velocity. V, it is v, it is u, that is v. Then v minus u is this. V is here, u is here. And when time is from here to here is time t, it is v minus u. So here area of triangle, this, suppose this is a point, it is b, here we come at c. So distance here will come v minus u is here, this distance, here. Area, this V minus U is this. Slope, this upon this will be slope of this curve. That is rate of change at which velocity of the body changes, which is acceleration A. So from here V minus U upon T is equal to A. Therefore we have V is equal to U plus AT, slope of the line. This is first case. Secondly, to derive S is equal to UT plus half AT square, make a figure like that. Here is U, suppose graph is going on in this way. Here is time axis, this is time T, S axis O, it is U. Then from here we have V, here is V, same motion is here. Then S is area of these two. S is equal to area of this plus area of this. Here is O, A, I have written B, C, and here is B. S is equal to area of OABE. OABE. Area OACD is U into T, length into breadth, V U into T, plus this area is area of triangle, that is half V minus U into T. It is V minus U, this is time. So it is UT plus half VT minus half UT. UT, don't multiply half, put this way, take T, take common, that's it is, right here, half V is U plus A minus U into T. This U, this way cancel, so it becomes half A square. You try to understand it. Area of the figure, because motion starts from here, goes to here, then distance will be represented by area of figure O, A, B and E. And it is second equation of motion which can be derived graphically. And to derive third equation, V square is equal to U square plus 2AS. Formula is the second equation. It is first equation. Here, whether we have space or not there? No, there is no space. So let us rub first, or let us rub both of these things, and by a fresh figure we shall derive the third one. The motion will be of similar third one. Here is this motion, this is time, this is x-axis O, A, B, here is D, this is U, here is V. So here also, if motion starts from A goes to B, then uniform average velocity is U plus V by 2, because motion is uniformly accelerated, so velocity can be taken as V plus U by 2, and time is T here, so S is equal to average velocity U plus V by 2 into time. From here And see, from first equation we have t is equal to how much? A t is equal to v minus u. So t is equal to v minus u upon a here. So 2s is equal to u plus v minus u upon a, which implies 2as is equal to v square minus u square, by which we have v square is equal to u square plus 2as. It is equation, third equation of motion. Thus, we have derived all the three equations of motion graphically. Now, in our book, circular motion is described here, though it should not be in your syllabus, but circular motion uniform, whenever a body moves uniformly around circle, it is always an accelerated motion, because at here direction of motion is this, at this point direction of motion is this. In this way, direction of motion goes on continuously changing, so velocity is changing irrespective of the constant speed. So in case of a circular motion, due to change in direction of the motion, the velocity of body continuously changes. Other things are here, I think irrelevant for you, and so here you prepare whatever I have taught. We shall do some questions from the end of this chapter, which will help you for solving the problems or numerical problems in your class or examination. So let us stop our video here, and we shall discuss the problems